This podcast is supported by Hannover Messe, your meeting place for the industrial community.
Hello, everybody, and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber, and today we are talking about AutoML. And my guest today is Professor Dr. Marius Lindauer from the University of Hannover, one of the most important AutoML researchers in Europe. Before we start talking about AutoML, Marius, please introduce yourself briefly to the audience.
Yes, thank you very much for inviting me today and for these very kind words already. I'm a researcher at the Leibniz University Hannover. I'm doing stuff in the realm of AutoML and related kind of things for the last 15 years. I have the pleasure of having a great team in Hannover for the last 5 years, pushing on the boundaries of AutoML and making it available to everyone.
That's the point, making it available to everyone. Because a few years ago, AutoML held great promise, right? Automated machine learning. Can you start by briefly defining what it means and then explain why we see, from my point of view, see so little of it in our industrial sector?
Yes, sure. So with machine learning, we have always the promise in saying that we have data, we somehow learning from the data and getting awesome predictions for a lot of tasks. The problem is that for different kind of tasks, we need different kind of learning schemes. Could be different kind of neural architectures, different kind of deep neural networks, but also different hypermodal settings, that learning rate, and so on and so on. It makes it hard in practice to use actually, and AutoML comes with a promise in automating these kind of what I call design decisions, how actually the model is learned. So that can help you to be much more efficient, to develop faster and better AI applications and so on. That's the main idea.
So that's interesting because you said design to help you to design, because some people define AutoML as like the vision was always that the domain expert works with a tool and as if by magic the AutoML works in the background and everything is quite easy. Everybody can do on machine learning.
Exactly. But I think there's more to it from machine learning perspective. You need the good data, right? Without good data, AutoML can't help you with anything. And then you also need to understand your use case, right? What you would like to predict. And that's sometimes harder than it might sound like. So how would you like to make money out of your machine learning use case? What is the business case behind it? What are also limitations of machine learning where AutoML also can't help you with, right? So one of the classic examples I had from industry, there was once a company working with me saying they would like to do something like predictive maintenance on one of their machines. And we showed them that AutoML can boost their performance quite a bit on the data they provided. And they were quite happy. They were saying, okay, let's use that. And then we're coming back a few weeks later, we're saying, Marius, that's not working at all. And I was saying, okay, why? What happened? And they're saying, yes, we now deploy that to different kind of machines, and that's not working. And I was saying, yes, sure. If you provide only data on one machine and you hope that by magic it's not working on all other machines, that's not going to be true. And AutoML can't help you with these kind of basic assumptions at all.
Were we too euphoric too soon with the topic?
Yes, to a certain degree, definitely. I think that was part of the marketing issue, which started around 2018 when Google and other companies are super euphoric about what AutoML will deliver and that everyone can now use it. To a certain degree, that was true in a sense that I know that many companies are using AutoML these days. I know that Siemens, Bosch, Beckhoff, and so on, they all have AutoML teams. They're using it in their day-to-day practice.
But not in a product, right?
Yeah, exactly. Not to the degree that AutoML was promised to be, right? It's not like the machine engineers now doing it. It's still more as the data science or machine learning expert using it. And then that's where this mismatch between expectation and more or less what AutoML can really deliver happened, right? It was like a lot of marketing bullshit happened. Let's be honest with that.
Is there also a mismatch between different perspective from your research? Because your research perspective is the industry, that means Amazon, AWS, Google, the big players, the big IT companies, and our focus is the industrial sector. And the AutoML research was focused on these big players in the US or the big IT companies?
I don't know about that point because we also work with the smaller industry partners in Germany. Also, we work with the machining faculty in Hannover, which is, as far as I know, the second largest one in entire Germany. And we had quite some success stories with that. For example, that there was one when I started in Hannover, this kind of case where people came to me and saying, Marius, you promise always this AutoML, everything works great. I was like, yeah, sure, send me your data, let me see what I can do. That was a milling task, actually, and I needed some kind of a digital twin for that, for airplane, super crucial for the application. And the PhD student working in the machining factory wasn't able to deliver after 3 months something which was really usable. It was good, but it was not really at the point where they could use it. And then using AutoML, we were able to show that within a minute, we were as good as the PhD student after 3 months. And within an hour, we were by a factor of 10 better. So we have these kind of success stories really showing that AutoML can deliver awesome models and awesome performance. And that's shown all over the place over and over again, I believe. The problem I'm seeing more with this mismatch between academic research and what really happens in German industry is that there is no good platform. There's no good ecosystem where people can build upon.
Oh, that's interesting.
So think about PyTorch or TensorFlow or Keras or so on. That's super easy to use. But what is the AutoML community providing? I don't know.
Some open source projects, right?
Yeah, we have awesome. Yes, definitely.
You have also open source projects, right?
Yeah, but that's not on the same level as PyTorch, I have to admit that, right? We with the Spray-Cutter framework, we develop awesome things like AutoScaler, which is downloaded 10,000 of times a month. So it's impactful to some degree. Or we have Max3 and so on. Or on the larger scale, actually, there's Optuna by Preferred Networks in Japan, has I don't know how many millions of downloads a month. Or there's AutoGluon from Amazon, also with this many dollars. I don't know the concrete numbers. So we have impactful tools, but I don't think we have an ecosystem where it's easy to build upon to make their own specific applications where people exactly know what happens there, how they can customize it actually to their use case. That's not there right now. And of course, we would need support by big industry partners to really make that happening.
Exactly. Who should build this platform?
Oh, that's a hard question, actually. I think it needs something as a collaboration between academics and industry, because on the one hand, we from the universities can't deliver a high quality tool which is maintained all over the place. We don't have the funding for that. And with tax money, no one is paying us for doing that. That's on the one hand, but I think we have the expertise. And for example, Optuna, I think, is right now the most famous tool for doing all this kind of hyperparameter optimization. It's well documented, it's super easy to use, but in our benchmarks, we quite often see that's lacking quite a bit of performance. It's never state of the art, but it's easy to use. And bringing these kind of things together, that would make a really big impact. And that could be a great opportunity for many industry partners in Germany. That could be something like Siemens or Bosch, but it could be also smaller industry partners. But we need a constant kind of collaboration where we really leverage the full synergies between academia and industry.
But the vision of AutoML is, from your point of view, still alive to make domain expert proficient in machine learning?
Yes and no.
Okay.
So
that's a typical researcher answer.
Yeah. Yeah, it depends, as always.
It depends.
Yes. Yeah. So if we are honest, after more than one decade on AutoML research, where we are right now, I think we are on a level where most of the time really more the data scientist, machine learning expert is using AutoML techniques. I think if you know what you're doing, many people using any kind of hyperparameter optimization because they know that hyperparameters aren't fault. They can't ignore that. They're optimizing their architectures with new architecture search and so on. So I think many people using our tools, but really more like on this expertise perspective. They know what they need and when they need stuff. I think we are still not at that point where really these non-experts, these domain experts can use AutoML easily. Because AutoML is still not good in saying what it can't do. And I think even more important, we designed AutoML for a long time like a one press button technology. And I really like this vision of deep learning, I don't know, 10 years ago, saying it's end to end. We provide data, some magic is happening, which we now call AutoML, and then at the end we have a good product. And that's, I think, is not true. And I think, I don't know whether that will ever be true in the next 5 years, because we need these domain experts in the loop, what we call these days human-centered or human in the loop assistants we also need for AutoML, because the domain expert knows quite a bit, right? They know what kind of data they have, what kind of constraints they have in their application, how large the model can be, what kind of energy consumption they can afford in practice, and so on and so on. So they have some knowledge about that. Why not leveraging that? Oftentimes, AutoML systems are still not built to really consider what the user needs in the end. And by simply pressing a button and hoping that magic turns out well after, I don't know, running for 2 days, many people are not willing to do that. That's a question of trust, right? But I think we need a new paradigm.
Okay. You mentioned the industrial sector. You mentioned the idea of building an ecosystem. Maybe the industrial sector is focused on other topics in a moment. We talk a lot about LLMs, and many see them as competitors to AutoML tools. What is your opinion on this?
I don't think that's a competitor at all. I think, on the one hand, large language models are amazing in how they generate code, and they can help you quite a bit in developing new, awesome AI applications. But that's only a different kind of perspective on AutoML. It's not a different thing. It's right. It's only a new tool which is available to the AutoML community or to AutoML users. And furthermore, people now believe that they maybe need AutoML less because now we have these big, awesome foundation models, but the problems are still remain the same, actually, even with having these large models, because for pre-training, you have to think about all these kind of design decisions, hyperparameters, architectures, and so on. And even for fine-tuning, it's the same problem again. How to do the fine-tuning? What are the hyperparameters of fine-tuning? Which kind of models do you have to use in the first place you would like to fine-tune, right? There was this very nice paper by Frank Hutter on quick-tune and so on, making these kind of decisions easier, and AutoML can still support you in all these kind of things. So I think right now what we're only seeing is that marketing went on and has a new buzzword, but the problems stay the same. And I still strongly believe that AutoML is still the solution to it.
Where do you see new opportunities, new fields for application for AutoML? You mentioned focusing on the data science team, perhaps as a source of inspiration for the data science teams, or as a certification tool, maybe. We had a discussion at our event about that. Can you please explain what is your opinion on that?
So, in this kind of vision for human-centered AutoML approach, where it's really like that both parties, so the user or the developer and the AutoML system, work together in a very synergetic way. I believe that AutoML can support these kind of developers in getting fast prototypes out there, right? To better understand what is the potential and applying now to the data, the best machine learning approaches, and then iterating together with the developer and getting better, integrating more insights, learning more from that. So I think that will help us to develop much quicker and much better AI applications, actually. And what you mentioned, actually, with this kind of certification is also another very nice perspective on it, because with the EU AI Act, of course, we need to have better documentation of what we're doing in developing AI applications. And the nice thing about AutoML is it's much more reproducible, because we have more these kind of button we can press and we do it again. AutoML can do a lot of recording of what is actually happening while it's optimizing. So what observing, whether we see any kind of fairness problematic, and trying out different kind of models and different kind of hyperparameters. It can also track energy consumption on the fly. One of my visions, for example, in the future is really to have also energy labels on the fly generated by AutoML, that people really know actually how energy efficient systems are. All of that can be provided by AutoML without a lot of effort. The only problem I'm seeing again is the ecosystem is doing that. But from the method perspective, that's all low-hanging fruits.
ecosystem means somebody needs to share ideas, needs to share perspectives, needs to share data, needs to share software, needs to share time with the community. What is your idea to building this ecosystem? Or do you say, oh no, I'll do my research, that won't work, forget it?
No, I definitely believe that that's possible, and I would love to be part of that. For example, we investing with Spec3, our hyperparameter optimization framework for many years, continuous support and making it better and better each week again. But that's all we can deliver from the academic part. Of course, what we need is partners who can share data, especially on how people using AutoML. We know, for example, that Google, with their framework on Google Visir, they have, I don't know how many 10,000, 100,000 of users, but they have a lot of them internally for all kinds of projects they're doing. And they have this kind of treasure simply in how people using AutoML, what kind of hyperparameters they're optimizing, how they are combined, how much budgets they're willing to invest, how often they would like to interact and see results and so on. That's this kind of data we really, really need in academia to better understand what kind of systems we should think about next. And then we can build our better system with the industry together based on that. So that's kind of data we strongly missing.
What else do you need?
With this kind of data, of course, infrastructure is always a big point. We can't train the very big models. We are always discussion with foundation models, but we can't also not easily store data, how people, for example, use now AutoML or machine learning. So we need storage, we need databases, and so on. And of course, we need manpower behind that. As I said before, we can provide ideas to a certain degree. We can also maintain our packages, but not on the level as industry needs it.
Mm-hmm. How can we bring a new momentum to the topic? What do the industrial sector needs maybe to see, oh yeah, AutoML is still there. Maybe it changed a bit, but now we have a new momentum.
Oh, that's again a very tough question. So parts of the communities are saying what we need is a solution to pre-training large foundation models. Like, how can AutoML support you with that? Because right now there's a lot of manual expertise being involved again, because it's so crazy expensive. Simply, if you think about training one of these models takes, I don't know, $100 million, you can afford it only once, and there's a team of engineers sitting there and babysitting more or less really the system that are training and doing all kinds of magic. Only they know how to do it. If AutoML can support also mid-sized companies in doing that on a reasonable scale, that would be fantastic. I think that would show the new value of AutoML. That's the one thing. And the other thing I believe where AutoML has quite a bit of potential is really on this kind of discussion, how expensive machine learning or foundation models are in general, also at inference, right? So even though that OpenAI and so on is spending hundreds of millions of dollars for training one of these big models, deploying open ChatGPT and Llama and so on and Gemini for even a week or a few weeks costs more than one pre-training, right?
Yeah, exactly. That's a big problem for the industrial sector.
Yes.
The inference is the biggest problem.
Yes. And I think AutoML had actually shown that it can support us very well in finding more efficient models. One of my examples recently was that we worked on deep shift neural network. It's not big transformer architectures, I have to admit that. But the interesting insights for us was that there was a paper from, I believe, 2019, where an expert team was sitting developing that. With what quantization, make everything much more efficient by at least an order of magnitude. And then we took that now again, this deep shift neural network, and we're saying, okay, can we apply AutoML to it? How much better can we be actually by applying AutoML? And we showed that accuracy can be improved by an absolute amount of 20%. So that's crazy amount, I believe. And at the same time, you can save 30% more energy, because it's not always intuitive. And we as humans lack sometimes expertise in understanding how that all of that works. Finding new design patterns back and even more efficient, and AutoML can help us so much more and getting inference time down. And I think that's one of the other holy grails we have to strive for. How can AutoML really lead us to efficient systems, sustainable systems, not so pricey systems? And that's something I believe is much easier than really solving the pre-training task.
Oh, that's interesting, yeah. What are you researching on with your team in the moment? What are the next steps?
So we have three big research directions. One, I mentioned already is this human-centered approach, really make this collaborative effort in developing new AI applications with AutoML in the mix. The second one is, in fact, what we call green AutoML, really making AutoML sustainable on 4 different levels, actually. So the first one is, of course, making AutoML more efficient, because people always complain, AutoML, come on, that's so expensive, it costs me so much money, I can do it better. So making AutoML more efficient, then making trading more efficient, then making inference more efficient on the third level. On the fourth level, still enabling AI for sustainability applications. If you think about climate change and so on, or waste and so on. I think these are the 4 levels we're caring about. And the third part I haven't talked about yet is in the direction of reinforcement learning, embodied AI. I think we all agree that the next big thing is not actually generative AI anymore, but as also NVIDIA and so on saying, is really how we can now build robots, how we can really bring it into the real world, these AI systems. And I strongly believe that one of the key factors is the reinforcement learning within that, of course, combined with foundation models. But reinforcement learning is a beast. It's a very nasty beast. It's super brittle, it's super hard. And if you're looking into reinforcement learning paper, it's not like they have billions of parameters in their models, but what they have is still like, I don't know, from a decade ago, very small, tiny models, and they struggle to train that. And AutoML can, I think, again help you to better understand why reinforcement learning is so brittle, to make it more robust, to make it stable, to scale better, and to enable with that the next generation of embodied AI systems.
And new architectures, right? Or what do you mean?
Yes, it could be new architectures, but also to figure out how we can scale from these smaller architectures to larger architectures in reinforcement learning. If you're really thinking that right now, sometimes they're using still NLPs or ResNets, I don't know, 15 or so. Nothing really close to anything which the computer vision or the NLP community is using. And we nevertheless know, actually, from the last 2 years, that what really makes AI strong is these super big models. But how can we train super big models in reinforcement learning? In an agent fashion, where a lot of information is coming all in all the fly.
Yeah, that's the big thing, right? Agents.
Yes, exactly. And I think agents will be all over the place in the future, and reinforcement learning is a key to that. I can't imagine how else you would like to do it, because right now with these kind of large language models, train only once every, 3 months is too rarely.
So we will see a revival of reinforcement learning.
I don't think that reinforcement learning is the only thing, but yes, I think it's a key factor in what needs to be done in the future.
And together with this revival, AutoML comes back or gets the new momentum.
Yes, I think it has the potential to do that. I've been working on that, and I'm fingers crossed that we'll be able to manage that. And I know that other groups are also working in that direction. Yes, I hope so strongly.
Who is also working on AutoML? Is it a European research community, or is it a worldwide community? Where do you see the most interesting papers when it comes to AutoML? Can you share a bit the research community perspective?
Oh, interesting question. So it's an international community. It's a bit maybe biased to Europe. I don't know exactly, but since also the big IT companies have AutoML teams, like AutoClue, and I mentioned before at Amazon, it's of course sitting in North America, but also have Europe teams on that. We have Optuna in Japan as one of the big teams and very important thing. And really we have all over the place teams. So if you're interested in looking into that, actually, we have a very nice new website called automl.space, where there's also a sub-page where we have a map from the Earth list with a lot of teams worldwide. Who are the most influential teams? It's maybe hard to say. Frank Hutter's team in Freiburg is definitely world leading. Also, this
they're now focused on TAP PFN.
Yes.
Everything in Frank's world is now TAP PFN.
Yes, exactly. That's a different discussion on how far we can get with TAP PFN, but he is very influential. That's super important. Great to have him in the AutoML community. But there are also very strong teams at different places. Also, Google DeepMind and London is still working on AutoML stuff. For example, the direction of scaling laws, how to make it applicable pre-training, and so on. So there are many amazing teams. You can, at least I would say in the realm of 100.
Marius, thank you very much for your insights. We are keeping our fingers crossed for your ecosystem, and anyone who feels that they have been left out can contact you and maybe talk about the ecosystem when it comes to AutoML.
Yeah, I would love to. Great.
Thank you, Marius. All the best. Greetings to Hanover.
Yes, thank you very much for inviting me. See you.
Thanks. Bye-bye.